Welcome back to Izzo Math. We ended the last video after deriving the formula for the law of sines and triangles. That was we talked about the Pythagorean theorem. Pythagorean theorem met the cosine. They had a little baby, and that little baby's name is the law of cosines. And think about it, the law of cosines. It grew up to get bigger than the Pythagorean theorem because it contains the Pythagorean theorem inside of it. So it's a little more powerful than the Pythagorean theorem. You know, like many parents have kids that grow up and be stronger than them. Anyway, let's look at what we got last time. So we had this triangle with sides A, B, and C, and we named the angles opposite the side the big letters A, B, and C. And it's really important to see these formulas here. There's A, there's big A, there's little b, side little b, big angle B, side little c, big angle C, opposite of it. With that notation of our sides and angles, we get three different representations over here of the law of cosines. So let's use it and use a little example where we have here we have a triangle. We're given all three sides and we need to find the angles. So pick your side, it doesn't matter. Let's start with 5 since it's the smallest. So what we would get is 5 squared equals 6 squared plus 49 squared, oops, jumping ahead of myself, plus 7 squared minus 2 times 6, I wrote a B there, 2 times 6 times 7 times the cosine of the angle opposite of 5. So that's going to be the cosine of A. Okay? So we're going to get that, just doing our algebra here, we get 25 equals 36 plus 49 minus 2 times 6 is 12, 7 times 12 is 14, 1, what, 84? Let me do that again. 7 times 2 is 4. 2 times 6 is 12, 7 times 2 is 14, 1 carry, so 84 cosine A. Okay? And now, so we're going to get 25 equals 9 and 6 is 15, carry the 1, 85 minus 84 cosine A. So now I'm going to send the 84 cosine A to the left and the 25 over to the right, and I'll get 84 cosine A equals, what's 85 minus 25? What's that going to be, 60? Okay, and we're going to get that the cosine of A equals 60 over 84. And I'm going to use my calculator to reduce that just to save some time. 60 divided by 84, enter. And if we go to math, fraction there, number 1, 5/7. Okay, so we got the cosine A equals 5/7. Now if I want to, so I know the cosine of A equals 5/7, so that tells me that A equals the inverse cosine of 5/7. So A is going to equal the inverse cosine of 5/7. So second cosine 5 divided by 7. So I'm going to assume that's degrees. It's going to be 44.4153. 44, so let's say approximately 44.4153 degrees, or if we want to get in radians, A is going to be about equal to, let's change my calculator to radians mode. Go to mode, go down to radians, enter, and so do the inverse cosine. Oops. Inverse cosine of 5/7. It's going to give me about 0.7752. 0.7752 rads. Okay, so that gives me A. Let's stick with degrees for now. Let's say A equals, or is about equal to 44.4153 degrees. Okay, so that gives me A. Now let's change colors here, and let's go for B. Okay, and now think about this. I'm going to use the law of cosines again, but I could use the law of sines. I could say that, let's see, sine B over 7 equals sine A, which is 44, it's about 44.4153 over 5. Now note, I could do that, and you might think that's easier and do that, but since we just now learned the law of cosines, I'm going to go ahead and use the law of cosines one more time here. So what am I going to have for the law of cosines? I'm going to start with, I want to find B, so I need to start with 7. So let me go to a new page here. 7 squared equals 5 squared plus 6 squared minus 2 times 5 times 6 times the cosine of, so 7, so I'm at 7 squared, and then I use equals that side squared plus that side squared, and then I have to use that angle opposite of 7 equals cosine of B. Okay? How are we looking on time? Okay, I got time to finish this one. So let's get 49 equals 25 plus 36 minus 2 times 5 is 10 times 6 is 60 cosine of B, and that's going to give me the 49. Let me take the 60 cosine B to the left, 60 cosine B over here, and I'm going to take the 25 plus 36 minus 49, and to save me time, I'll let the calculator do the work there. 25 plus 36 minus 49 and give me 12. So I get 60 times the cosine of B equals 12. Divide out by the 60, and we get that the cosine of B equals 12 over 60. And what's that going to be? That's 12 and 1/5. Yes, 60. 5 times 12 is 60. Yes, so we're good. Cosine B equals 1/5. That's going to tell me that B equals the inverse cosine of 1/5, and so B is going to be about equal to, and I'm going to stick with degrees for this problem. So let's mode, go to degrees, enter. I'm going to do the inverse cosine of 1/5. Second cosine 1 divided by 5. That's going to give me that this is 7.4630. Oops. It's about, let me erase all 3 of those. Okay, what was it again? 78.463. Okay, so that tells me 78.463. This thing was 78.463 degrees. Okay, looking good on time. So I've got those 2 angles there. So to get the angle C, I just use the fact that there's 180 degrees in a triangle. So C, so angle C is going to equal 180 minus A plus B. So C is going to equal 180 minus, what was A? 44.4153. 44.4153 plus angle B, 78.4630. So give me C is going to be about 180 minus, let me put my parentheses there, 44.4153 plus 78.463. And about 57.1217. 57.1217. So that's going to complete 57.127 degrees, and that's going to complete this example of an application of the law of cosines on a triangle. Look forward to seeing you guys in the next video.